So this is supposed to be a workshop, so what I'm going to do is try and, I'm going to talk about a few things. I'm going to try and keep that to maybe 15 or 20 minutes. If I do it right, it shouldn't be beyond that, so that we have the rest of the time for everyone to try out some of the stuff that we're doing. We'll try and go step by step. We're not going to be too ambitious, but it's always a little bit harder to go through something the first time and try and get all of the cogs to fit. So that's really my main goal here. So I'm going to talk briefly at the beginning, and then I'll give you some setup instructions so you can kind of get a little bit set up in parallel, and we'll get down to some stuff. So I'm Adam Breindel. I've got this tag that says independent, and I realized walking around with this that, you know, in the academic world, that strikes fear, because you see somebody that says independent, and you're like, are they going to be talking about aliens or how Atlantis is the assassination of JFK? And don't worry, I'm not going to talk about any of that. I have some grad work in classics at Brown, and I mostly work in private industry now in the software engineering world as a consultant and trainer. So I design and build a lot of software systems, and I've been writing a lot of teaching materials and doing a lot of training. Last year I did most of Cisco and Salesforce.com in North America, JavaScript training. So at the very least I know how long it takes to do even simple things in a workshop. So I'm going to move on quickly. Virtualization and platform as a service. So this is a meta topic, right? We've got classics content, and we've had a lot of great talks about process, about how to develop classics results. And then this is a sort of, I guess this is really a meta topic, because this is about the process of how to build the tools that we can use to do digital humanities work to then come up with classics results. Although being meta, it's not a talk about postmodernism. It's really very practical, especially thinking back to Greg Crane's talk yesterday morning. With his vision of opening up, as widening the vision of classics and opening up the data and the tools to as much of the world as possible. So a big part of that is getting the data and building the tools, and another part of it is doing it in such a way that it will scale out. I forget the statistic he offered, was something like a couple billion people theoretically could have access to this, and that means that if you're building an interesting tool, you need to be able to have a couple of billion people coming to your website or your tool and not have it fall over. So we need to talk about that. So why? Motivation is that many digital classics projects are brittle, and it's not really the fault of any of the researchers, because your goal is to build something to test an idea and to develop interesting results, right? So it's my job to try and make things less brittle. But what I'm trying to do is share a few tools that we can use to develop those things in a way that will go further. So these are some of the reasons. I won't read through all of them, but basically we have a lot of projects that are dependent on very specific people, very specific machines at certain institutions. There are projects that go extinct. I was just talking to a gentleman just not even an hour ago, was talking about something that was built for PowerPC. And so it's like desperately clinging on some PowerPC Macs to run this thing. So that's just one example of how we have to consider the possibilities. I have a couple of examples. One which I figure if I'm going to criticize something, I should point at my own project. I did one at Brown that had to do with stemata for manuscripts and cladistics. A number of people have done work like that. And so what are some of the mistakes I made, right? Mine was hard-coded to a Win32 API, right? That runs today by the grace of Microsoft, certainly not any cleverness of my own. What else? So the only thing you can find online about this now is the paper, which is really ironic, right? What I had is a digital tool and data sets and results. The only thing that's left up there, you can find the paper. The paper survived, right? The software, good luck. So that's sort of the problem. I can look at my own work and say, well, how can we do this? So what we want to do is to fix some of these challenges. Right now it's hard to spin up new instances of a project, to be able to point a button and say, oh, we're having a conference today, we're going to have a bunch of people visit this at a poster session, let's just spin up 9 more of these, right? Or I want to test out some changes, let's spin up a new one that looks like the old one and make changes somewhere else. It's hard to take with you, so if you're going to a conference and you happen to be going somewhere, and it's the basement of Oxford and there's not good connectivity, you might be stuck. I mean, you want to be able to have something that's portable. Because portability is, in space and in time right now, is a little bit analogous to portability over the long haul, right? If you can't move it on, from place to place now, what are the odds it will be around in years? We also want these things to be reproducible, so that if you do this work and we take your results seriously and we cite them, that if somebody else comes along later, they could have a hope of reproducing that. They're not taking it on faith that, well, one time one person got this to happen. We have no idea how they did it, because if we can't reproduce it, then it's kind of magic. So it doesn't have the same level of sort of scholarly sort of reliability. We also want, like Greg was talking about, people to be able to remix and reuse this stuff. So we want to design our systems more like Lego bricks that people can, people can attach and reuse, and not like custom molded parts that stand alone and then we have to start all over again. So luckily, most of these issues can be mitigated. There's a bunch of ways to do that. I'm not going to try and talk about everything here, but there's a few steps in that direction. So one of them is SOA. It's sort of a component-oriented architecture, and that looks like it's already got really good uptake. I'm really excited talking to people and seeing a lot of the projects are they're already being designed around APIs and separation of the front-end clients from the APIs and all that sort of thing, and the intention of interoperating between. We saw a lot of that with the GIS and the geodata-related projects, that the goal is to tie them into lots of other digital humanities systems. So that's great. And another thing that I want to focus on here are virtualization and platform as a service. So those are a couple of ways to get some more leverage over this process. We want to try it out here. We also want to be careful to maintain sort of academic integrity and not have a lot of IP encumbrances. So especially in the academic world, it doesn't matter if some corporation comes along and says, I've got this awesome tool, it's proprietary, I'll kind of give it to you for free. I mean, we all know that that leads to a lot of problems down the line in terms of the global community of scholarship. So we can't have that. We need not just free as in beer, but we need open source software as much as we can. So I'm going to stop here for a second and give a little bit of chance to set up, and then I'll talk a little bit more while you set this stuff up. So to do what we're going to do here, we're going to look at some services and virtualization in the cloud. So I know that as part of an abstract talked about virtual machine image, and given the time frame of the presentation, I thought, I don't want to sort of waste everyone's time with half an hour of trying to download a gigabyte of some sort of software and get it configured, and that's not really all that much fun. And we can actually look at some even more advanced stuff purely with a browser. So if you have a browser, and I would say pick an email. You don't have to use your official email. You may have other accounts you don't want to contaminate, so you can make a disposable email right now. Go to Gmail, or I'll do a demo right here with Mailinator, so it'll be completely open. You can steal my accounts later if you want, but you just need some email for this. Once you've picked an email, then we're going to make accounts on 3 different services here, and these are all going to connect together. So the first one is github.com. I know a lot of you guys have projects that already have software in GitHub, so you may be familiar with GitHub. If not, it's a combination of a cloud service, software source control system, and a social network. And we're going to focus just on the source control part of it, because that sort of has become the dominant way that a lot of this sharing and collaboration goes on. So we're going to make an account there. We're going to make an account on this thing called Cloud9, which is the c9.io. And that's actually a cloud IDE. So there's a whole trend we're going to talk about development environments in the cloud and in the browser. And don't worry, they don't replace your own local tools. They interoperate with your local tools. So I'm not going to stand up here and argue that all that stuff's moving into the browser, but for a demo like this, it's really handy to have. So if you sign up on there, and then the last one is Heroku.com. That's a platform as a service that's currently owned by Salesforce.com. There's some issues where it may not be the preferable one for academic use, but it's the best one to try out today and get the concept. And we'll talk about options that are maybe more open later. And it's at least free as in beer to play around with. So maybe if I can find a marker, I'll write those up on the whiteboard so I can proceed to the slide deck a little bit. Is there a marker? Ah, I don't see a marker. Okay. Okay, so I'll wait a couple more seconds. At the very least, if you're interested in signing up and you haven't done it yet, then just copy these URLs down into some sort of a notepad or something like that. GitHub.com, c9.io, Heroku.com. You can do all of those with any email that you want. Use the same email for all of them to make life a lot easier. Also use the same browser for all of them, at least for today. Just for the workshop, it'll make things a lot easier. Okay, so now a brief history from of how we get to this platform as a service and what it actually is. So step one, emulation. We talked about the power problem. Classic example is this PowerPC issue we talked about, right? We have PowerPC software. How are we going to run this thing in the future? Well, what we want to do is write a program that seems to the program that we're running like it's a PowerPC. It's not, but as long as the program that we're running doesn't know, it doesn't matter. So you can think of emulation as being a bit like the Matrix, right? It's we create a pretend environment, and as long as the thing is inside that environment, believe in it, then it's fine. So we're not going to do emulation in here, but it's part of the sort of panoply of things that we've got. In the long run, everything ends up in emulation. So think about that from the scholarship and time frame point of view. No matter what you do today, if it's around in 50 years, it's going to be an emulation somewhere. So that's where things are going to end up. For now, we're going to look at virtualization. So virtualization is a twist on emulation. Basically, emulation is expensive, meaning it takes a lot of work to create a simulation that's convincing to the software that's running. Virtualization is a little trick. You can think of it as being less like the Matrix and more like the Truman Show. In the Truman Show, if the character is playing a game of tennis, it's a real game of tennis in the real laws of physics on the real earth. It's not pretend. It's just that when he goes to leave, someone gets in his way and comes up with an excuse for why you really don't want to leave, and that the sky out there that he thinks he sees isn't actually real. That's basically the way virtualization works. The software you're running is running on real hardware, and so for that reason it has good performance. But it's not allowed to leave, and the trick is to make it not realize that it's not allowed to leave. So the technical way that that's done is not important in here, but that'll give you a little bit of a model, sort of a metaphor for what's going on. So examples that you may have seen played with already of virtualization are desktop virtualization. So at the very beginning of the talk, I made this silly joke about the previous talk, which I was running in virtualization. I just minimized and closed that virtual machine. If you have a Macintosh, you're running Parallels, or you're running VMware on your Mac, you've already got desktop virtualization, whether or not you think about it that way. That's how that stuff works. If you want a free one, there's a free product called VirtualBox. So originally I considered doing that in here. That's free as in beer. I don't know the exact licensing on it. I think it's fairly openish, but I'm not 100% sure. And so VirtualBox is cross-platform and it's free. I think it's relatively open. And the VMs that we make with those tools they're portable, standard, easy to use. So that just by itself gives us a whole bunch of leverage. I built some complicated project. You want to try it out. There's a point-and-click way to export a virtual machine image from VirtualBox, throw it on a thumb drive, or throw it on some kind of shared storage, and now you're running it. So just that by itself gets us, in some cases, well ahead of where we are today. I'll do a demo of that really quickly, even though I kind of already did that. I've got a Tesserae virtual machine. Tesserae being one of the projects that was demoed here and being developed right here at Buffalo. And I'll give this guy a minute to spin up. I'm going to have to kill it and restart it here. Nope, it's coming up. So just so you have an image, if you haven't played with this before, just so you have a picture in your mind of what this looks like. I don't know why it's taking so long. I think I will kill it and restart it.
What was the third thing you said to sign up for?
Let's see, it's GitHub, Cloud9, and Heroku.
Okay.
Heroku. So here we have a Tesserae virtual machine. I'm just not going to go into this in detail, but just so you can see what it looks like. Right inside of here is the Linux box. It's configured with some of the Tesserae stuff. And I was able to get this just by email from one of the folks here at Buffalo. So that's really handy. But it also leads into some of the not say downsides, but some of the difficulties of desktop virtualization, which is that by itself, right? If we come over here into the VMware player, it's like, what do I do now? Right? It's what I'm trying to do is figure out which parts of Tesserae installed on here, how are they set up to run, if I'm already an engineer interested in the project, that may be really useful, but depending on how widely I want this to spread, it gets somewhat more difficult to use. And there's a little overhead. I'm still dealing with a machine. It's a pretend machine, but I'm still dealing with a machine. So what we want to do is get from virtual machines to the cloud. So I'm going to do this really quickly, but this is where we're going technologically. As we start out with machines like we just saw, that can be easily copied and cloned and moved around. And then we say, well, hey, if we can do that, then a data center maybe can be a whole bunch of virtual machines instead of a room full of racks and physical servers. And we can move the virtual machines around as we need to between the host servers. And then somebody gets the bright idea that, well, maybe we don't even need to worry about the underlying operating system. So on our desktop machines, we care a lot about that, say Mac OS. We have Windows running on top of Mac OS. But in the data center, we don't care about the underlying operating system. So we say, well, let's just use this thin shim called a hypervisor that gets us from the hardware of the server directly into our virtual machines. So we have a hypervisor there, and we have hardware that almost all modern processors are designed to support efficient virtualization. So we can actually skip that and get right to a data center that consists purely of virtual machines. And if we can get there, then we can say that since our machines are actually virtual, we can write software that controls those machines. So instead of having a data center in the old sense, where it's like, let's go buy a server and let's pay for a place in a rack and a power connection and somebody installs it and all that kind of stuff, we can create elastic servers. So we can say, well, if I need 20 servers worth of compute power, I can programmatically create 20 servers worth of compute power. And when I'm done with the hard job and the data set is rendered and I just want people to visit my site, maybe I can scale that back down. So the systems that we're going to be working on are designed around this model, that very few tasks require lots of servers all the time. And so the big change has been from in the old days where your company or your university had to buy as many machines as you needed for peak usage to satisfy everyone, and the rest of the time they were idle, to a system where you can sort of pay for the service on demand, whether it's a university or a corporate environment. And that creates a lot of efficiencies, right? You don't have all this just idle, very expensive hardware sitting around. So the result of that is what we could call a machine cloud. The best known example of this is Amazon's EC2, or Elastic Compute Cloud. There are lots of these. Again, I'll mention some that are more open. You can run in-house in university. These are basically farms of servers that you can access, and you can provision servers out there. I'll show you just a very, very quick demo. I'm going to show you just the control panel for one of these. So this is the control panel for an Amazon EC2 account, and you can see in here, this is just the EC2 part. If I go back one, these are all the different Amazon services that run in the cloud. You can acquire or create versions of these. And in here, you can see that I can, if I wanted to launch another machine, I click this one button, and I'm launching a server. It's as simple as that. And it's a server that's based on an image that's well known. I don't need to go in there and install anything. And I can do all this other sort of operational stuff sort of straight through this page. So that's kind of nice, and I have some links down here. You can see just on Amazon, obviously they want to promote their own business, so they have a library of AMIs, Amazon Machine Images. The generic term is a virtual appliance. There are tons of companies out there that have libraries of virtual appliances, so if you want to do something, like you want to do some giant data processing task, in a lot of cases you don't even need to think about what to install. What you can do is say, well, okay, if I'm doing open source and I'm doing big data, maybe there's some other universities, some other project may actually have a machine image that I can just deploy. And it's set up, and so it gets me out of that whole operations end of things. So that was sort of the demo that I just did. I have a one nota bene in here, which is the one thing you can't easily fake in virtualization is RAM, because the characteristic of RAM is that you can get data to and from it much more quickly than the alternatives. So at some point, sooner or later, somewhere you need to pay for the memory that you need, but you can borrow that sometimes. And I'm going to skip over this for time, I think. Okay, so the next step we want to go up the stack here, what we're going to experiment with in a little bit, is PaaS, or Platform as a Service. So Platform as a Service goes one level beyond machine cloud type virtualization, and we say, well, let's not worry about the machines, because the problem with all that other stuff is they're more efficient than physical machines, but at the end of the day, you've still got a machine somewhere. Somebody, there's still software running, and if it breaks, even if it's a machine image you didn't configure, you need somebody who's going to log in and do that operations work. So we'd love, as humanities people, to get out of the operations business. Honestly, even in the software world, it's not pleasant. It's never pleasant. It's very time consuming and difficult. If you ever had your machine break, imagine that just on a bigger scale, right? You're fixing machines. So we want to get out of that business. And that's where this comes in. So platform in this sense means the collection of tools and components that our application is built on. So I have a few examples up here. There's as many platforms as, it's a combinatoric thing, so you can make up as many platforms as you like. But examples would be, say, Ruby on Rails with Postgres. So Ruby is a language, Rails is a framework, Postgres is a database. Hopefully there's some operating system underneath there, but in theory you shouldn't have to care. Java, EE, MySQL, there's an example. JavaScript, Node, Express, and Mongo, there's another example. So each of these are a platform. What we'd like to do is find some place where we can just say, I've got an app that is written as one of these. I want to deploy it. I don't want to care about anything else. And that's basically this slide here. So as long as we work on one of these provided platforms and we kind of get our code in the right shape, the system we're dealing with will do everything else, right? It's not that it doesn't have to happen, it's that we don't need to worry about it. It means we do have to package our app in an appropriate way. If we don't package our app right, we can't deploy it there. But that's actually a little bit of good discipline, because if we couldn't package our app right, then probably sooner or later we're going to run into problems in terms of the longevity of this thing. So it will force us to get our stuff organized the way we want it to. And then we get all these advantages if we do that. So it's simple, we can share, we can collaborate, other people can run our code easily. We're going to do that in about 5 minutes. They can work on our code or our data sets. They don't need to know about the operating system. Because here we have people from every kind of background. Teaching, we have graduate students, we have undergrads, we're talking about sharing projects with. The idea that you need to do some Linux administration as a prerequisite to this, it's not ideal. We also can get vast compute resources temporarily, right? So if our university has a big compute cluster, we can say, we need that for 1 hour every month to update our data set. We're going to scale out to 50 nodes for that. But the rest of the time, we're going to run on this one little node that we can operate nearly for free. So maybe it helps our department as well. A few other examples, these sort of come along with that. It's free as, most of the stuff, or a lot of it is free as in beer, a lot of it's free as in speech. It's much cheaper, unless you're using high compute all the time, like a render farm for movies or something, it tends to be cheaper. And it saves human resources, right? Which is, we don't want to have ourselves actually need to do that. So this is how we do it. We arrange our app in a standard way, we push a button, and we go. So in terms of moving forward, you'd have to pick some sort of platform as a service. We're going to look at Heroku in here. This is a very small list. There are probably 50 or 100 companies that can be on a list like this. These are just some of the major ones. I would take a close look at OpenShift, which is connected to Red Hat. That seems like it was the best fit at the moment for academia in terms of you can run it on-premise, you can run it in their cloud, it's under a relatively permissive license, you can get the code that makes up the guts of the cloud. So if your university says, well, we're not running a cloud that we're tethered to some company for, I would look at something like this. And there may be others coming, but I think OpenShift is probably the first one. And so we're gonna actually do this in a second. So we can actually write our code in the cloud as well and get all these pieces playing. I've got a couple links here that are nice to look at. Coding with a K is an invite-only beta. CodeNB is another really nice platform. We're going to look at Cloud9, and there are some other ones. So we'll see Cloud9. These are just some other ones you can look at. And let's just get right into trying it. So, okay, so log into GitHub. And I'll do this along with you. I'm going to make a new account, so if it breaks, it'll break for me just at the same time it breaks for you. I'm going to make a new anonymous window here, so that has no cookies or anything connected to my regular world. And I'll sign up for accounts on here. So I'm going to make, I already had test H1, which I used for preparing some material for here. So I'm going to make somebody called test H2. And his email is going to be testh2@mailinator.com because I'm not going to keep this around. And I'll make a really simple password, and we're going to sign up. So your GitHub thing will look like this. And what's the step we want to do next? So we want to create a new project and select the checkbox to include a README file. So the button for that is up here, where it says create a new repo. So we're going to click here. And I'm going to leave this public. I'm going to click the checkbox for initialize with a README, and don't worry about this thing down here. Let's see, I can give it a name. So I'm going to call this DCA demo. and create repository. Okay, so now I have a repository that lives here in GitHub. Okay, so I can't do too much with that yet, but I've got that piece. The next thing I want to do is log into Cloud9. So just like you guys, if you haven't used this before, I'm going to come in here and do a sign up for a brand new account. And I'm going to do my free sign up. And I'm going to call this one also test H2. And I'll set this as test H2 at emulator.com. And I need to check that email account to activate it. So I'm going to go over to here to test.h2.emulator.com and get the invite email. And there's my invite email. Click this button to activate my account. Set a password. So you may already have this set up, but if you haven't, this gives you a chance to at least see what it would look like or follow along. And I get this dashboard that comes up like this. So it comes, there's a demo project sitting in here. And we can take a look at what the demo project looks like. Click there and click Start Editing. Hopefully it will start. Do a little refresh on here. Doesn't want to start editing. Okay, well we don't actually need the demo project for the demo we're doing, luckily. What's going on here is that, remember I talked about all this stuff being elastic and on demand? So I'm actually going to be accessing a virtual machine. We'll see I even have a console in that virtual machine through Cloud9. When I create a new account on Cloud9, it's actually provisioning me space on one of those machines. And it's a little bit more than just provisioning a user account in the database somewhere. I actually need to be able to have a shell. It creates a whole account for me, and that sometimes takes a little bit of time. So I'm going to move on while I'm waiting for that. So the next thing I'm going to do is over here. So from the Your Account dashboard in Cloud9, we want to activate the GitHub entry. And that's going to integrate my system here to GitHub. So if I click this Your Account up here, then down here under Add-on Services, I can click Activate. And it brings me up this basically an OAuth window to authenticate into GitHub and allow Cloud9 to mess with my data. So now Cloud9 has read-write access to my GitHub stuff.
I'm sorry, what did you click in?
So up here under Your Account, that brings up this page. And then down here where it says GitHub, under Add-on Services, it says GitHub. If you click Activate, depending on what you've done before, it may or may not actually pop up that other pop-up box. Sometimes it's already set to go. But you may need to click OK. And then once I did that, now notice over here on the left, I've got another project entry. It says DCA Demo. This is the one that I just created, this empty project that I created over in GitHub. So I'm going to click this button and I'm going to click Clone to Edit. And what that's going to do, what Clone to Edit means, is it means suck down the source code for this from GitHub, make a local instance of it that's tracked against GitHub, and then get me in a setup where I can edit it and run it. So the source URL is already filled in for me. I'm just going to pick, what am I going to pick for this? I'm going to pick Node, because the little sample that I have is a Node app. So leave open and discoverable, pick Node over here, and click Create. And it says Cloning Workspace. And so now I've got this showing up in my projects here. So now I'm going to click Start Editing here, and hopefully something happens. And this is my editing window now. So I've got a folder structure here for projects. Down here on the bottom, I actually have a terminal. So if you do miss the days of doing Linux stuff, you can do that locally, but you can do it right here. We've got a command line down here. We've got output from our apps. We've got our one file. This is the README that was auto-generated for us by GitHub. So there's nothing much in here but some markdown text. We're going to add some stuff into here. And you can kind of play around with this, but there's a number of online IDEs. I'm not suggesting that this is the best one or the only one. This is the one we're using for today. And it does have really nice integrated debugging though. So for example, if you want to debug your code on the server side, it's as simple as throwing a breakpoint right in here, because you can actually work your server code and your client code from the same place here. The visual debugging tools for this are very nice. Okay, so we've got that part wired up. So what do we want to do now? We want to come over here to step 5. Okay, we've got step 5, we've got step 6. Next thing we're going to do is go to step 7. We're going to actually put some code in here. So far we've got an empty repository. So under the Workspace Files tab, we're going to right-click on the project folder and do New File. So I'm going to demonstrate that. We're going to go here, right-click, we're going to go New File, and we're going to type in server.js, because this is actually going to be a server-side code file, and it's going to be in JavaScript. So I'm going to click that, double-click over here, and I've got a place where I can edit. And now I need to put some code in there. Well, we're not going to write a whole bunch of code in here, but I wrote a little example you can take, and you can get it from this URL. So if you go to gist.github.com/anonymous, which is a place where you can put little snippets of code you want to share, and put slash this number here, 5321996. I'll do the same thing. We'll see where that comes up. So if I put that in here,
Sorry,
we get.
that was really fast. And I couldn't pick up.
Oh, I'm sorry. Is that? Oh, is it off the top of the screen? Oh, I'm sorry. You can't see the whole screen that I can see. And
You just go back to the PowerPoint.
Yeah, I should have made a short URL for this. It's always easier than typing something like this in. So what I'm going to do is I'm actually just going to copy the code right out of here, and I'm going to come over and paste that. Normally I'd be writing some application code, but I'm going to paste that into my, where's my Cloud9 editor window? So I'm going to paste it right in here. So I've got my JavaScript, little hello world DCA 2013. So this is a complete server app written in Node. It doesn't do a whole lot, but it'll scale like the devil. That whatever URL we ask it for, it's going to just write back hello DCA 2013. So we've got this in here. We can actually test this out right here inside the Cloud9 environment. If I click run over here, it says my code is running, and there's a couple of ways to preview this. If I click this link, I get a little pop-up in here, and I can see that it's running, and this is actually live. If I put this URL somewhere else, it will actually work. I'm not going to deploy my app here. I mean, I don't want end users using it because this is still a development environment, but it lets me actually debug my code. I can put breakpoints, do all the development process stuff that I might want to in here. But what I want to do now is, I just killed it. That says temporarily unavailable because I clicked the stop button up here. But my goal for the next step is I go, okay, cool. I've got a GitHub repository. I've got Cloud9 hooked up to that. Now what I want to do, I've made some changes to my code, so I want to do two more things. I want to push those changes back to GitHub, and then I want to deploy this for the whole world to use. And I want to do it in an easy way. So I'm going to come over here to Terminal, and it's going to get a little bit geeky here for a second, but I think at this conference everyone's pretty happy with that. So first thing I need to do is add the changes, and I'm going to send it back over to GitHub. So what I'm going to do is I'm going to go git add dot, and that basically tells Git, which is this version control system, to track additional files, like the one that I just created. And then I'm going to do a git commit. Put a message in here. And now how do I get this back to GitHub? So I'm going to go git push. And I'm going to let the system do all the work. And now if I come back over to my GitHub account, and I refresh the page, you'll notice it's updated, right? I've got some stuff from C9, I've got my server code is in here. So that's all synchronized, and this is a public project, so anybody in the world that just copies this URL can now get a hold of my code. You can also share with them through Cloud9. Most of these IDEs are also envisioning themselves as kind of social networks, and I don't really want to endorse one over the other. I'm not sure what the best workflow is, but you can collaborate with people directly through those environments. So that gets me to here, and what I want to do now is deploy it. So to deploy this app, we want to send this over to Heroku. To to run it. So the way we're going to do that is we're going to come over here. We're going to click on the balloon. So the balloon icon means deploy. So the upper left, we're going to click the balloon icon, and we're going to create a deploy server. So over here, I'm going to click the plus to create a new deployment target. And you can see there's a few choices here. Different tools have different choices. Some tools are designed to support lots of choices. Some depend on what platform you're using. So there's a lot of variation here, but this is straightforward. For here, we're going to pick Heroku.com, and I'm going to click Sign into Heroku, and I'm going to give it my Heroku credentials so it can work with that system. Sign in. Let's try that again. Email or password or incorrect. Oh, I didn't sign up for Heroku with this new account. I should probably sign up first. Let's do it. So I'm going to come over to Heroku, sign up. Go back to my URL to confirm my sign up. Give myself a regular password. Now I've got an account on Heroku. Heroku is really delightful. They were one of the very first people to really do platform as a service and get it right. Probably the other old one was the Google App Engine is another example. But Heroku, again, it's like I'm not even suggesting that it would be intellectual property-wise appropriate for academic work, but it's a beautiful environment, and you can from here not only can deploy all kinds of apps, but you can add on other things. So you want to add a Postgres database or a Mongo database or some sort of messaging service or Memcached or any various other pieces that you might want to add onto your system. Most of those can be connected through point and click, and you can see your apps. That stuff goes under add-ons. So if you click under add-ons, you can see a huge gallery of things that you can get. Almost everything in Heroku has a free tier. So almost everything in here you can use at least some of for free as an appearance. So at least for something like undergraduate projects, that should be not a problem. Going back to here, trying to deploy. Now I can actually sign in. So it says your Heroku apps, and if I wanted to deploy on top of an existing app, I'd see that in this list, but I don't have any Heroku apps yet. So I'm going to go create new. I'm going to call this DCA demo. And I'm going to go add. So now I've got a deployment target. And now, okay, I want to deploy this thing. So it's as easy as clicking the green deploy button. Oh no. Yes, fix whatever you have to fix. Let's try it again. Oh, because I'm missing some files. This did not work. Okay, we're going to fix that. We need to add, remember I said in order to deploy to a cloud platform as a service, you need to package your application right? Well, I didn't package my application right. My application's okay, but I need two other files. I need a package.json. So I'm going to go new file, package.json, and I'm going to come in here. And basically, this is a way of declaring my dependencies. So let's see. Rather than work up my memory, I'm going to steal from one that I already have working, just so I get this right. There's sort of a minimal one you can put in. I'm going to go to my Cloud9 account over here, and I'm going to steal one that I know works for this demo. This one. Let's see. Yes, okay. So package.json is where it's a way of describing, it's like a manifest file in some environments. It basically tells a system that sees your project what the dependencies are, so that you don't need to worry, because that's a standard problem, is how do you manage dependencies. So here what we're going to do is we're going to put in a name, a version, and I don't think you even need the rest of it, but it wouldn't hurt to have it. So I'm going to copy and paste this, and I'll wait so that you can type it and catch up, because I know I'm kind of cheating on you here by copying and pasting stuff. I hate when people do that. But while you're doing that, I'll talk about it. So the name is just a name that helps the host deal with it. Version is because every time we adjust this, we're going to want to increment the version. We want to be able to manage where we are in that version list. And then engines are the core pieces here. We're relying on a version 0.8.x or better of Node and npm 1.1.x. And in this list, if you were using, say, a database, your database driver and other pieces would show up in this list, and Heroku would automatically fetch those and install them for you. If you connected to my GitHub repository and I had a complicated project and you want to set it up and you didn't have the dependencies, if I write this package.json, all you type is npm install, and that's part of the Node environment. That will look at this manifest, install all the dependencies, and get you up and running. So I'm going to save that. And the other piece I need, there was also a slide which I went through quickly, which is that for each of these platform as a service systems, there's at least some little bit of hint you need to give it in terms of instructions about how to deploy your app. So these vary from pass to pass. In the case of Node on Heroku, all we need is a single one-line file. They have a system called Foreman that they're using, and we need a single one-line file that tells Foreman how to start our app. And I'm going to steal that from here also. And that's really easy to copy because it looks like this. It's called procfile with a capital P. And so I'm going to create in here, new file, procfile. And I'm going to edit this guy. And in here it's just going to say web:// node space server.js. You can probably guess what that means. The node refers to the node process that's going to run my app, and server.js is where it's going to start. So it's sort of like main. So I'm going to save that, and I'm going to try and deploy again. So let me add all this stuff to my local repo here. Okay, now let's try this one more time. Here. This is bumming me out. My deployment isn't easy. My whole demo is less persuasive than it really should be. Well, I'm going to try one more trick before I give up and move on to a different demo. So is anybody following along and has theirs working? Because the process actually does work. At least some of the time. So what I'm going to try is I'm actually going to restart this whole thing here. Being a web browser, it keeps track of your state. So if I refresh the page, it actually comes back to where I was. Let me try one more time. So I've actually got this app on Heroku. You can see it exists here. And if you come under your Heroku account and you click Apps, you'll see this. You'll see your app in the list. It's just, unfortunately, not actually running, which is always a risk with the cloud. That is very frustrating. If anybody knows if I'm doing something wrong here, please feel free to tell me. But I don't think I am. I think that I've seen this before, and it occasionally happens. But I'll skip to pretending that it worked, or I'll run the one that I had prepared ahead of time over here. Here, let's try this one. I've got this demo project. Now my demo seems a lot less fake. I mean, a lot less real because the one that I was doing didn't work. But if I click this version that I was testing over here and click deploy, why am I getting that? That's very strange. My app is already running over here. If I click this and I wait, it should actually come up. So it is actually running. So this is something about the integration between Cloud9 and Heroku is acting up a little bit at the moment, and that's part of the fun of being on the bleeding edge. But in any case, it's not like my assets are lost or anything. And here I actually do have a version that's running, and you can't see because I'm off the top of the screen. Which is down. So this is the test version that I was doing when I was putting together some of the material here. This is running on Heroku. And Heroku is running on Amazon EC2, although they do a really good job of hiding it from you, right? I didn't have to mess with any of the Amazon stuff. I don't even know where that virtual machine is, right? Amazon's got data centers around the world. I don't know where that machine is. I don't know what operating system is on that machine. I don't know what size instance it is or if I'm sharing it with someone else. I don't care. What I care about is that my deployment before didn't work, and in this case that this thing does work, right? So I'm focusing on my application running and doing what I want. And if I want to spin up, there's a little slider on Heroku if you play around. If you want to scale your app up to some enormous amount of scale, you just slide the slider. And of course the price increases as you slide the slider. But the point is, from a workflow point of view, that's basically the workflow, is drag the slider and pay the bill, which is a lot nicer than all the other stuff that we sometimes have to do. So I'm going to do one more very quick demo on here about collaborating, and then maybe we'll have some questions, and we'll probably be running out of time at that point. So this is just a little Hello World app. I wrote another app which is almost as trivial. See, it's living in my repo over here. I have a GitHub repo set up under this guy. Okay, so I have a couple other projects. So I have a couple of really simple projects here. A little client-server thing that simulates a backend. This is a REST service that stores data, but data doesn't actually go anywhere, but it's fully functional. And then I've got a client, which is like a little cute little JavaScript client that lists some stuff that you can navigate around. So the question is, supposing you wanted to share it, like you wanted to work with me on this project. So I've done some work, and I want to give you this link, and you want to try it. So we'll take a look at what that looks like. Let's start with the service, because we need the service first. Here. So I get this URL over here. So this GitHub URL, this is a fully public project. If I want to share this, so I'm going to copy it and I'm going to switch browsers to the browser that doesn't know about this browser. So I'm going to come over to this Cloud9 account over here. And so this is the test H2. This would be sort of your account where you don't know anything about my account. And I'm going to go create new workspace, clone from URL. So I'm going to come in here and I'm going to right click. I'm going to paste that GitHub URL. I'm going to click create. And you can see, I don't know if you can see, it's kind of hazy there, but it says DCA demo service processing, this little gear spinning. So it's pulling down my code from GitHub, creating a local instance of it here. Now it's done, so I click start editing. And now I'm working on this DCA demo service app, which is a little bit more complicated, just because I put it on Express. But if we want to, I think it actually has all the pieces with it, so there isn't really a big install step here, but we could do an npm install if we wanted to. And we can, let's say we want to edit this, code, we can go change it around. I've got some stub data in here with some text in here if we wanted to add some text or mess around with it. And then we can try running this also in the environment on Cloud9. And we can preview it over here. We need to pick the server file. So if I come over here and I go /works, which is the URL for loading up this data set of works, I've got a couple of Aeneid works, Breindel works, and links to Perseus and whatever. So I've got this service running over here, and I can do the exact same thing for the client. So I can actually just leave that running. But while that's running, well, I'd like to start up the client for this project as well. So I'll come over here, do the same thing, grab the demo client code, switch back. Create new workspace, clone from URL, paste. This is actually a JavaScript client app, so I'm going to say HTML5. And it looks like that one's ready. And so let's see, I still have this guy running over here, and over here I've got the client. So let's run the client, point it at the server, and see if it actually works. And since this is not, all we have to do is view this, I can just click the preview button. And let's see, I've got something running. Is my service still running? My service is running over here. got my client running over here. It came up for a second there. Let's launch this out and see what happens. Well, at the moment, these two aren't connecting, so I'll see if I can get them connecting. But the point is not the logic of the specific program and the architecture of the specific program, but the main point is that I've got something here, in this case, a little bit more complicated. I've got a server piece, I've got a client piece, and to actually get those running as a third-party collaborator, it's really just about pasting and pushing a button. And if I wanted to deploy my own version of this server, so now as this test h2 character, if I wanted to deploy this, I should be able to go over, and who knows whether this will work or not. We can try it. But we can try and deploy that. Right, okay, let's call it server. Today is what? 6th. See if we can deploy this. Okay, so we've got a little more action going on down here. We get some status messages. And it's doing some work. And we don't have to read through all of this right now, but it basically, we've got deployment succeeded. Application is available here. We open this in a new window. And see if we can get something running over here. Okay, well, this is misbehaving, and you can only argue so much with technology in a short time slot, so I'm not going to. But the overall workflow does actually work. And what we're also looking at is not the specific workflow between, say, Cloud9 and Heroku, but the general idea that what we're building is software using a particular platform, following the constraints of that platform in order to have well-defined components, and that we can then easily deploy those into a cloud that gives us an abstraction of the layer of the kind of application that we're doing. And we're independent of machines. Assuming I can get this running, if I want to run 100 of these, I can just click 100 times. Of course, I really want to run 100, and I'll write a script for it. But that it gives me the ability to share this out and sort of operate these things at massive scale without doing any of the infrastructure work for it. A few of those things you need to make some architectural arrangements in your application to accommodate that, but that's a different kind of discussion. So that's pretty much what I wanted to present. We've got 1 or 2 minutes left, so we can see if I have anything else. We can maybe do some questions or something like that.
So at the end of the process, is it possible, so again, coming from our test project, say, that you could have multiple, I think of browser windows essentially, running different instances of the software?
When it's fully deployed?
Yes.
So they actually get fully deployed to totally separate places. So if you have, like in this case where I had sort of an originator and a collaborator, if they both deployed and they were working separately, they would be deployed to separate hosts.
Okay.
I mean, we don't know for sure under the hood whether they're separate hosts, but for practical, logically speaking, they're actually totally separate hosts. So they can be totally isolated instances. Yeah.
Just to expand on that, if you're using version control, then you can deploy 2 different versions of it. So you could deploy it to one server, you can test ride 1.0 and make changes and compare them. Right?
Exactly, and what it does, it makes it easy to do things that big companies do that sound hard, which is have a test server, a QA server, a production server, change the version, and move it through those servers, that sort of thing. That sounds like a real pain, but when you get to a process like this, then it's really not so painful. Absolutely.
The work I did that is coming up in the next session, I did something this week that was kind of a disaster, and I think I could see how I could have done it better using something like this. And what happened was I had developed all the code on my computer, In the meantime, I upgraded my operating system this week, which I know I'm never to do again. I've learned a mistake. So what going from in this case with Lion's Mountain Lion on what it is upgraded the version of Python I virtual coded. So I went from version 2.71 in Python to 2.72. It also broke all the dependencies for Python that I was depending on. Now this seems a way of solving it. If I had developed this all this way, nothing would have changed, correct? I mean, because it would still be using the version of Python that the servers run.
Yeah, if you had developed it on here, then you'd be all set. Now, I'm not going to say, well, you should do all of your coding that way, because I think there are, I mean, like the glitches that we see on Cloud 9 here they're not the only ones I've ever seen. I'm not going to go, oh, yeah. I mean, they're not. And some of the other products are not even as mature. So this is the cutting edge, but you still probably want a local version. But
Of course.
But what you can do is by keeping it synced, you have another version somewhere else that had its dependencies declared that was stable. So at least if you were getting up here like me, you wouldn't have to have a word break because you'd be pointing to one that was, that was solid.
Right, okay.
And then you would eventually have to, wrangle your Mac to get it back.
But I wouldn't have had to do
But
it
it wouldn't
yesterday.
Exactly.
Yeah.
You wouldn't have had it yesterday.
Okay, thanks
Cool,
very much.
thanks.